All right, school interface 1. All right, so I open up school interface 1. I'm going to fork it over to my personal GitHub, Tom Preet. So it's copying it over, school interface 1, Tom Preet. It's forking over. And now I'm going to clone it down. So I'm in my, zoom in a little bit. All right. So I'm in my Oscars challenges. I'm going to list everything out. I've got all these challenges here. I don't see school interface in there. So I'm going to git clone school interface 1. I'll list everything out. And now I can see school interface 1 is right there. I'm going to CD into school interface 1. Okay, I'm currently in the school interface 1 directory. I can list everything out. I can see that README in there, the data, the runner, and the school.py. And I'm going to open this into a new VS Code window by doing code space -r space period. It reloads VS Code with school interface 1 in the root explorer directory. All right, so let's go over and look at what we're building. So again, this is one of 4 school interface. I think it's 4 school interfaces. This is what we're going to eventually be building, is a command line interface application that will eventually look like this. But after school interface 1, it's not going to look like this. We're just going to be slowly building upon and eventually get to this interface. So here we are. So for this challenge, we'll be building a simple interface for a school that will keep track of student records. There will be many ways to create the functionality we are looking for, and you should feel free to experiment beyond the scope of this tutorial. So just quick note, this tutorial is pretty comprehensive and is meant to challenge you. Some steps are deliberately vague to force you to do your own research and debugging. Don't get discouraged, help each other out. All right, and they're depending on some of this, until we go over, okay. All right. You might want to do this right here. It just says ignore it until we go over inheritance. But if you wanted to, you can definitely keep building upon that. All right. So let's just first explore what we're working with. So we have this runner code. And can someone tell me what the runner code is for?
It's kind of like our main. It's where you're going to enter into the program and do everything that you're going to do with it from the runner. That's like where all your classes are getting access.
Yep. So essentially the runner is the runner file. When you run your program, this is the file you're going to run, and everything will pretty much be executed within the scope of the runner file. So you'll be importing a lot of stuff just like we just did here, etc. All right. Then we have the school. So we have a school class. Can anybody give me a description of what like a class is? Just like an analogy of what a class is, or I would say an object.
It's like a user-defined type, so it can be whatever the user wants it to
be. Okay. Anybody else?
Yes.
It's a blueprint so it's a blueprint for what you're trying to do. Like we did yesterday when we made the class dog and cat, and we added class attributes, instance methods, and other items that we need to add.
Yep. Yeah, that's really good. So yeah, class is exactly a blueprint to something, a blueprint to something we're creating. Can someone tell me what like an object is?
An encapsulation of data and methods that
Yep. Yeah, that's actually like the simpler, like an encapsulation of data and methods. But when we hear the word school or student or person or staff or dog, what do you think? Whenever I think of objects, I actually think of like a physical object, like a dog or a school. It's like something physical that has specific attributes to it. But yeah, I was just wanted to get y'all. Did somebody else have something?
I was going to say a noun.
A noun, like a person, place, or thing. Is that what that is? I'm horrible in English.
Yep.
All right, cool. Whew, got that right. All right. So it looks like right now we have 2 Python files, a data folder. So let's just explore this data folder. I got staff. So staff.csv file as well as a students.csv file. Looks like we have headers of name, age, role, school ID, and password. We're staff, we have name, age, role, employee ID, and password. Okay. And we'll be reading and writing from that data. All right. All right, so keep our organized. So we bring the code. So in the runner file, I'm gonna split the screen here. So in the runner file, we said from the school file, import the school class. And what is happening on line 3?
You're just assigning a school attribute, or like the name of the school.
So
Aren't you creating an instance of
Yeah.
the class?
yep, that's what I'm looking for. Because right now I'm passing an attribute. I'm passing Richmond High, a string, into school, but I'm not actually assigning it anything in the school class because there's nothing happening right here. But yeah, school, I'm creating an instance of a school. So I'm literally building a new school from scratch. And that's what this variable school is right here. It's the new instance of this school class. So if I wanted to, and just print a school, let's just run this Python runner. So, I get an error. It says type error, school takes no arguments. And I look over at school. I literally just have a class school and I'm just passing. Like there's nothing actually happening in school. So if I actually just wanted, with the current way the school is created, if I just initialize school with no arguments, because right now, can everyone see? Should I zoom in a little bit? There we go. I'm just gonna zoom in. There we go. If I run this again and I just print school, Python runner, there I have a school object. So I initialized a new school object right here. That's what school is. But let's just go back, because that's what we want to eventually do, is pass in some information about the school. So in here, when I initialize a school and I want to pass in arguments into the school, I do def dunder init. And then it always takes in the self keyword and then maybe the name. I think that's all I want right now. Let's see. And then self.name. And the reason why I'm doing self.name, because I'm looking over here in the runner, and school has a name attribute or a name variable attached to it. And I'm going to assign that to the name. And what's dunder init do? What is this?
It's a magic method.
A magic method?
It's basically your constructor function, right?
Okay, what's a constructor function?
It initializes the variables in the class for that current object that's being created.
Mm-hmm. So anytime I initialize, exactly, Sarah. So every time I initialize the school and pass in whatever arguments, this init dunder method automatically is invoked. So this is always called every time I create a new school, no matter what. So I can even, let's just test it out. I'm just gonna print this is invoked. So if I were to not even print that, so if I just sort of invoke school or create a new instance of school, it's going to come into here. It's automatically going to run this dunder init method. It's going to assign this Richmond High local variable right here to self.name. And then it's going to print this is invoked. So if I clear that and come down here in the terminal, print that, it prints this is invoked, even though I'm not actually physically invoking like dunder init. Like I'm not actually invoking that manually because it's automatically invoked for me every time I create a new instance of the school. All right. And I mentioned that I pass in Richmond High as an argument into the school. So anytime I want to pass in arguments into a class, I can continue to pass in more arguments, like another argument here, and then I can keep, just like I'm passing in like a method, just like I'm passing in arguments to a method, like some other argument, etc. So I can keep on passing that stuff in. And I'm passing Richmond High in as an argument, which we skip the self argument because the self literally refers to oneself. So self, I think of self as it refers to this specific instance of a school. So it refers to oneself. So the arguments you pass in come after the keyword argument self. So the name is a local variable right here, and I'm assigning it to this variable called self.name. What is self.name? What kind of variable is that?
Won't be an instance.
Yep, it'd be an instance variable. And what is the difference? Like, what is the purpose of self.name? What is an instance variable?
I guess it's just like contained to, or like it's just linked to the instance that you create for the class. So like pretty much like the member object of the class that you created in Runner.
It's a pointer to the class.
So
actual objects.
I'm sorry, say that.
I said the creation of an actual object.
It creates an actual object.
Isn't it just like a piece of data that's inside an object?
So yeah.
That variable is referred to the new object.
Yeah. So
it's accessible outside the method. Makes it accessible outside the method.
Are you saying, Musa, did you say it's accessible outside of this init method?
Yes.
Awesome. Yep. So I heard a bunch of people say some things, but yeah, the self.name is an instance method, which is accessible outside. It's essentially accessible anywhere within the school class. So if I had like another method called print school name, this is going to be an instance method, and I can just what is it? Print self.name. So here's a method, an instance method that takes in the keyword self. So let's just run the Python runner file, Python runner. And right here, I'm saying school.name, which school is the school variable and is an instance of this school class. And I'm assigning this name to self.name. But now I can access this self.name variable by calling the instance of the class, which is called school. This is a variable .name, which is an instance variable right here. And if I wanted to do print, actually I'll do return self.name. Print school, so the instance of a school, I'm going to invoke the sprint school name method by invoking it like that. So this method is a method on the school instance. So if let's actually comment this part out. Runner. I get Richmond High again because it comes in here, prints the school name, invokes that, returns self.name. So the self.name is accessible anywhere within the scope of this class. If I only did self.name like so, I get a little highlight. Even though I brought in name here up on line 2, this name right here is only available within the scope of this dunder init. So between line 1 and 3, actually on line 3. That's where this name variable is only accessible. But by doing the self.name, because I'm reassigning it, I'm able to access the self.name anywhere within the school class. So if I were to run this, I will get an error saying name is not defined, because name is just a local variable within the scope of the sprint school name method. And I'm not defining it here at all. So that's why I need the self dot keyword in front of it, because self dot name is an instance variable. Now I have access to the self dot name throughout everywhere within this class. What questions do you have about instance variables? Oh. All right. No questions?
Yeah, it just takes a little practice to remember to refer to all of the instance variables with self dot after using Java, where you just use the name itself.
Yep. No, yeah, I mean, that makes sense.
So
Yeah.
in runner, where you print school.name, what is it that's making name visible there?
What is making this name visible?
Well,
or
in runner, school.name, .name is a variable at that point.
It's an instance variable at this point.
Right, and it's visible, apparently visible outside of the object, right?
Well, it's not accessible outside of the object, because school is the object, and I'm accessing the instance variable name within the school object.
But not every variable in school would be accessible in the same manner as we're seeing it accessed in runner, right?
I believe so. Let's see. Local variable equals.
I think, Tom, I think all Python names and methods and classes are public, so they're all accessible outside of the class definition.
Okay, so if I do school.local variable, yeah, I guess it would.
Yep, that's not an instance variable. That's just a variable in the function, though.
Right. So this local variable is not accessible on this class object.
So apparently the fact that we put the self dot in front of name and made it an instance variable, every instance variable would be available outside the object by accessing it with the object name dot variable name.
Was that a question? Sorry. Or
that was an observation that got reactions.
Yeah, sorry. So if I wanted to do, so if I wanted to create another school 2 equals school and Bard, and I did school 2, these are two separate objects with two separate school names, or two separate names.
So if we in school, if we let's say in that print school, print school, if we said that self.fred equals Fred, could we then print school.fred in the other program?
Only after, so yeah, that's a good point. So yeah, school.self.name. So you can declare instance variables within any method inside of your object or inside of your class. However, the self.Fred will not be accessible until you invoke print school name. So if I were to try to do right here, school.Fred, which, okay, Fred is an instance variable. And I'm going to clear this terminal and run that. I'll get an error saying school object has no attribute Fred. And that's because I haven't invoked this print school name method yet to actually declare or define a self.Fred instance variable. But if I were to do print school name like so, and then do print school.Fred. So I create a new school object. I'm running school.name, which is an instance variable right here, self.name. And then I'm invoking print school name. So I'm calling this method, which is then creating the self.Fred instance variable. And then everywhere else, I should have access to self.Fred or school.Fred. So if I run that, now I get that too.
So that answers my question and works the way I'd expect. Thanks.
Yep. Sorry. So if I do that, cool.
Incidentally, I had concerns about my audio yesterday. Is it sounding okay?
Yeah, I can hear you.
You're come through good on this end too.
All right. I think there was also just if you want to know what attributes are assigned to a specific object, you can do dir, a method directory, and pass in that object. So I'm gonna clear the screen, do Python runner, and now you can see all the built-in methods, all of the different attributes, all of the different instance methods, instance variables that are attached to this school object. So it's an array right here. We have this dunder class, dunder, I don't even know what any of these are, dunder dict, dunder dot, what all these dunder methods. And we have the dunder init, which we're already using. But if you go all the way to the very end, we have name, which is an instance method, and print school, which is the print school instance method or instance variable or method.
Hey, Tom, I forgot to go over the help method. If I could go over that, I think that also displays some useful information.
Let's do help. So yeah, what is this? Oh yeah, so I never really used the help method. So methods are defined here. Yeah, this is actually really cool. So methods that are actually created within the class, we have the dunder init. And then we also have this print school method. Is there anything else that we usually use this for?
That can show you like class level attributes if you created them. I'll just give you more description of them.
Sweet. Also, this dictionary for instance variable, if defined. Interesting. Cool. So we might see this at some point as well.
What did you do to spit that out?
What did I do to spit that out? I just put help. It's a method called help, and I just throw in the school object in there.
Thank you.
Cool. All right. So let's go back. Kind of got ahead of ourselves. All right. So we also want to create an array of students and staff. So I'm just going to get rid of this print school name because we can just access the school name by just doing school.name there. And then next, let's do self.students equals an empty array, and do also self.staff and make that an empty array. So right now, a lot of times, this is where keeping track of the data flow of an application comes in handy. Initially, we've been working in just like a function. That function does something, and it's done executing. Now we're actually building an actual application where we're going to have different files and different classes, and that data is going to flow between all the files and be stored in different areas within the program. So it's kind of hard initially to kind of visualize where the data is flowing. So it's really good to like step through each part of the program to see where the data is flowing. All right. We'll start by initialing our school with a name. Feel free to add other attributes as well. Notice the school will be responsible for keeping track of students and staff. Since these will be large collections of objects, we will use a list to hold them. So the student, these self.students, is literally going to eventually be an array of objects. So it's not just going to be an array of names of all the students. It's going to be an array of objects, of student objects. All right. So now we can create our students and staff classes. All right. So we can clear that. I'm going to list everything out. So I'm going to create two files, touch student.py as well as staff.py. And I'm going to code student.py and staff.py to open up in this right here. So student and staff. All right. So I'm just going to copy this over for the student. So we can kind of just walk through what did I just do? I did that for staff. So let's get rid of that. And then let's also do that for staff. All right, so here we are in the student file. So the student class has a dunder init that takes in self and takes in the name of the student, the age of the student, the role of the student, the school ID, and password. And we're assigning all those to instance variables using the self keyword. Self.name, self.age, self.password, self.role, self.school ID. Now, notice how we name age as the same as the instance variable. You can, in theory, say like student age, and everything will be fine. So you don't always have to name whatever argument is being passed in as the same as the instance variable. However, it's generally best practice to keep things named the same thing, just so variables aren't changing what they're called throughout the program. Same with staff, takes a name, age, role, employee ID, and password. So very similar. So ignore this portion until we go over inheritance. You could be proactive and read about how inheritance works in here. Would you like me to go through this part or just wait? Anybody?
It's not really that complex, is it?
No, but we'll go through it. Yeah, so we'll go through it. Let me see real quick. So yeah. Oh, what the hell is going on? All right. Should have closed some files. All right. So what can you see about staff and student? Are there any similarities between these two?
Everything but their IDs.
Everything but their IDs are relatively the same, right? So what's one level below a student or staff? Like, what is a student and staff? If you extrapolate what a student is or a staff is.
They're people.
They're people. Exactly. They're just people. So we can extrapolate this, and what can we assign to, if we wanted to like make it one level greater or lower, we can create a person class. .py, person. All right. So I'm going to create a class person, and this will be dunder init, and we can take in self, and we can just like say, all right, name, age, and what else do we want? Employee ID, password. We just kind of, what is all the same? So pretty much everything's the same except for what, school ID, right?
And employee ID for staff, yeah.
Right, so we can keep those separate, but as far as all of this stuff goes, name, age, password, role, we can name age as a role, password. I just want to see what password. All right. Let's actually split that screen over here and bring that over there. All right. So in here, we can do self.name equals equals name, self.age equals age, self dot role equals role, self dot password equals password. All right, so that for that. So now we can technically get rid, I'm just going to comment this out for student right now. We can get rid of all that. But okay, so we don't want to repeat code. So we're like repeating code here. But we can now, when we talk about inheritance, when you hear the word inherit, what do you think about?
That it comes from a parent class or a parent attribute.
Okay, let's actually break it down outside of coding and programming or OOP. What do you think about when you talk about inherit?
Something gets passed down.
Yep, things that are being passed down from, you know, relatives, your generations before. So yeah, like my parents both have blue eyes. I have blue eyes. So I inherited that attribute or that trait from my parent. And then they inherited specific traits from their parents, etc. Like my dad is Italian and pretty dark. My mom is Irish and very pale skinned. I inherited the pale attribute from my mom's Irish side. So you can inherit specific attributes from your parent or your super class, as they say. So person is the parent class of student or the super class, and student is a subclass of person. So in order for student to inherit attributes from person, I first need to import from person, import person class. And now the student class needs to inherit person attributes by running person. Whoop. Like so. So the student class, little parentheses, and whatever I'm inheriting from the person class. So now it's like, okay, so now I actually need to invoke the person class in here. So I can even go person dot dunder init and add, put in name, age, what am I not, role, and password. So in here, I'm doing person. I'm like literally creating a person object. I'm invoking the dunder init, and I'm passing in the name, age, role, and password. I think I might need the self keyword in there, but I don't know yet. We'll see. So if I wanted to actually run this, let's just try to test this out. So what this is doing is, yeah, let's test this out. Tom equals student. I'm creating a new student class. The name is Tom. The age, 35. Role, student. School ID, 123. Password, XXX. There we go. Oh, that's JavaScript. Clear. And now I'm going to list everything out. I'm going to clear it. And now I'm going to run the student Python file. Uh-oh. What did I get? Role name, role password. So it says Tom student. Here I'm getting an error on line 10. Right there. So line 10. All right. This is where the error is occurring. Person under init name, age, role, password. Type error, init missing one required positional argument password. And I've got the password right there. But if I look over here, I've got 1, 2, 3, 4, 1, 2, 3, 4. But I'm missing the self keyword. Let's just put that self keyword in there for right now and see if that works. Maybe it works, maybe it doesn't. All right, cool. Nothing that means it didn't error out. That's always a good sign. So let's actually start printing some attributes. Tom.name. So Tom.name isn't, we're not invoking it within the init, under init in the student class. We're actually invoking it in the person class. So passing in name into the person under init, comes into here, name, self.name. It's being assigned there. So if I run that, there we go, we get Tom. We can also do age. And let's just do school ID. Just to make sure that the school ID is also being assigned in the self. Cool. So now the student class is inheriting all the attributes from the person class. And you want to keep your code modular and reusable, because maybe I want to create, instead of a student and staff class, maybe I want to create another class like admin Python file that has very similar attributes to student and staff. So instead of creating a brand new admin, like administrator class that has, all of these in here as well, because I'm repeating a lot of code, I can just inherit from the person class. So it's all about keeping your code modular and dry.
I've got a question, Tom.
Yep.
Is there a way that we can confirm that Tom is an instance of person, like the?
I don't know if we can actually confirm that it is an instance of person. Does anybody know?
I'm sorry, student is an instance of person, just to make sure that we have it like linked up properly.
There's a is instance method in Python that will. There's also a is subclass method. Sorry, I think that's one we want to use. So you could do. You want to do dot. You would just do, I think, is subclass and pass in the object you want to check, and then
like that?
The class. Yeah, it's something like that. You want to, I think, also pass in the class you want to check against. So is Tom a subclass of person? So the second parameter would be the person class.
Yep. So
I think so. Yeah.
Cool. Let's check that out. Oh.
All right, I guess that's checking for classes. There should be a way to do it though.
Yeah. Yeah, I don't know off the top of my head, but yeah, that's a good question. But you can also do, I think it's help. Just see what attributes. I don't know if this is helpful. Or student, person, built-in objects. Yeah. All right. So we're now inheriting from the person class. But say our application is, hundreds of thousands of lines of code. And for whatever reason, our CTO says, you know what, person isn't descriptive enough. Let's actually change this name of this to like human. Now, everywhere within our application that's inheriting from the human class, I would have to go and change that to here as well, like human. So everywhere in our application, I'd have to go ahead and change that. So instead of doing that, there's a shorthand on how to call the parent class every single time. So it always will call the person class in here. And there's a keyword called super. And the super will always invoke whatever the parent class is and automatically do exactly just like we did with person. But the difference between that is that we don't need to include the self keyword in there. So when in doubt, always use super when you're initializing a parent class. Any questions about that?
So is the main point? Oh, sorry, go on.
Let's see. So super is kind of like it's a one step below the object class. So it's like the highest of the, I guess.
Yeah.
Do you see what I'm trying to say? Does it always end?
It will always call the parent class.
Okay.
Are you saying like if there's multiple parent class, if there's like a grandparent class?
Yes.
et cetera?
Yes.
I believe it will. So if like person was inheriting some other human class, like something like maybe there's a level below that person where it will, I believe, if I'm not mistaken, it'll always just call the most direct parent class. It won't call your grandparent class or great grandparent class.
Okay, so that's like directly, okay.
Yep.
So it's going to be whatever's in the parents in your class student.
Yep. All right. So let's go ahead and refactor the staff as well to include the person as well. Import person. So person. Now let's actually just comment that. Now here, do that. Employee ID, where am I getting an error from? So employee ID, role password.
I think it's just a tab issue.
There we go. Thank you. All right. Let's assume that works. All right. Now we can refactor with dict and quargs. Ankur, did we cover dict and quargs in a later lecture?
Sorry, what was that?
Do we cover dict and quargs in a later lecture?
I went over that a bit yesterday,
Okay.
basically when writing to a CSV file and reading from it. So yeah, if the students need to go over it again, definitely that would be worthwhile.
So I usually don't like to use the dict keyword, but we'll go over quargs and args. So there's two types of things. There's args and quargs. Args, so if I wanted to pass in right here in the staff, if there's like a bunch of like, say this method I want to invoke having like 20 different arguments passed in. There's a way we can do like multiple arguments by doing args, or as they said, quargs, which is keyword arguments. So for example, where is it? I'm just going to copy this student info down here. I'm going to do name, Tom. password XXX, school ID 12345. Yeah, sure, that works. All right. So instead of passing in all of each individual thing in here, I can literally just pass in like, or actually let's do this in for student. There's student info. Maybe I just wanted to pass in an object in here. So like student info. And right here, the init wants to take in 5 different arguments, but the student info object is just one argument. So what we can do is take this over and running quargs or student info, something like that. And here we can pass in student info, but for this purpose, let's just keep this the same like so. And let's see what we want to do. Or actually, yeah, let's just do student info. So here, let's just, before I'm going to comment this out. I'm just going to print student info. Student info. And invoke this. Uh-oh. But 2 are given. Oh, so right here, I'm passing in an argument. So I believe I have to do that. Let's see. It's been a while since I've done this. There we go. So with the student info object, when I do the double asterisk, I'm saying pass this student object in as a keyword argument. So it's exactly like taking that object and saying name I'll do name equals Tom, password equals that, school ID equals, was it 1, 2, 3, 4, 5, and so on. So when I run this double asterisk into the student info object, it's literally like extrapolating it and passing each value as a keyword argument. That's why it's called quargs, keyword argument. And so here, if I wanted to get like the name, I can do something like that. Whoop. Oh yeah, that's not going to work. But if I did that, I can extract like the student name by doing student info.name, because this accepts keyword arguments. So I can create an object like so, and it's just easier to pass in, just create an object instead of having to pass in every single argument like it was before, like with the name, Tom, etc. So questions about keyword arguments or quargs?
It looks like it would be harder to error check.
Yes, it would, and that's why I'll kind of show you how this works, and then I'll probably revert back to it the normal way. But with that, I kind of want to show you like if I wanted to keep adding this into so under student info, if I wanted to use keyword arguments and pass that into here, I can say student info. So I'm passing the student info as keyword arguments into the person class. I'm just going to comment this out. here. So this will take in student info as keyword arguments. And instead of assigning each individual variable in here, I can like do like student info name, student info age, and so on and so forth. But that's
Did you have to import the student file over to the person file if you're going to do the quarks like that?
no, because I'm not actually using anything within the person or within the student file, because I'm literally passing in just like a student object in when I'm invoking the student and just passing that object into the person class.
With what you're doing right now, the student info has a dozen items, but the person that, and a lot of them are student related, not person related. So the person just looks at the ones at once and ignores the rest.
Yes. So right now it just ignores all of what I don't want. So yeah, so student info is passing in even what else? The school ID also in here, but I'm just ignoring it inside of the person class. But that's where the dict keyword comes in, which I'll just kind of show you how that works. I can do self.dunder dict. So remember that dunder dict method. Actually, I'll just kind of show you update person, or I guess it would be student info. I just kind of want to show you what that looks like. Now, if I do Python student print Python student, if I do print dir Tom clear. So this dict, if I were to just grab, where is it? The dictionary, it would show all of, let's actually see. Just want to see if this works. It's probably going to air out. So this dictionary shows all the all like the instance variables attached to this object. So what I'm doing here is I'm passing in the student info, which is as a keyword argument. So this name, this student info object, I'm passing it in as keyword arguments into the student class. And then passing that student info into the person class as keyword arguments. And now it's an object right here again. And I'm just updating the current dictionary within the object with that student info. But as Don said, initially I was just extracting what information I want out of the student info and applying it, like the name, age, role, and password. However, here I'm also extracting like the school ID as well, which is not necessarily what I want to do. But I can also, go ahead.
Sorry, I'll just wait till
That dictionary in person is not persistent, right? I mean, it's going to just be there for a moment and gone.
I think it assigns instance variables to it. So I can access tom.name, tom. Like role, and all of that. So it persists throughout everything. But I just kind of want to show you that, but I'm going to revert back to, as Sarah said, that this is all fine and great because it's literally like 3 lines of code, but again, it's not that readable. And again, you want your code to be readable. So if you skip the keyword arguments and just left it like so. And get rid of all of this and go revert back. Like so. You can even keep this as like student info, but then in here, just extract student name or student info name, student info age, and now this still should work. So if we still wanted to use keyword arguments, uh-oh, what am I looking at?
Hey, Tom, before we get too far ahead, could I just ask you a question about that person class, how we had called the keyword arguments? Can we go over that just real quick? How student that was calling person, how that actually accepted the quarks, even though it wasn't initiated or the person isn't actually in. I guess I'm just lost in that connection. You know what I mean?
So when it was like this.
Yeah, and then the person class was accepting the student info quarks, because I guess I'm just lost on the connection between the student person versus the class person, and how the quark was acceptable in person when it wasn't linked or importing that class from student.
So it doesn't have to import the class from student at all. So right here, the student info object, again, it's just an object with name, password, school ID, age. I'm passing the student object as keyword arguments into the student class. So I'm invoking, creating a new student. The student info comes up here. It's being passed in here as keyword arguments right up here. And then I'm following through and passing that information into this super dunder init. So these keyword arguments into here, which is referencing the super method, which references the person class. So I'm passing this, I'm literally just passing in the student info as keyword arguments into the person class, come over here. And then when I had the code previously, oh geez, this was accepting student info as well. Or I can call this like person info, because again, this is just.
Okay, that makes a lot more sense. So the super class was initiating that. Okay, I see what you're saying now. Thank you.
Yep.
So would it be safe to say that the parent would inherit the children's attribute as well?
In this case, it's not inheriting it, but it's being passed into the parents.
So it just kind of has like access to it then.
It has access to it, but then we get to choose in the person class what attributes we want to extract from the student info. So
okay,
we might not want to access all of that. But again, this isn't very readable. I don't really like it, but like it's just another way on how we can pass in. Just be aware of that there's a keyword arguments where you can pass in stuff by using the double asterisk, and it passes in an object and extracts it just like you would like an object.
I like what Sarah just put in the chat. Looks like it simplifies the init.
Cool. All right. What'd you put in there? And the questions? In
the Zoom chat.
Oh. Can't see. Awesome. Yeah, that's even simplifies it even more. Awesome. All right. So let's just clear that. See if this works. What's going on here? All right.
Line 11 again.
Oh, thank you. There, that works. All right, so just be aware that there's keyword arguments that we can pass into functions to make it the arguments, instead of passing in like a bunch of arguments and making sure that the order of those arguments are passed in correctly. We can just pass in a single object or a single keyword argument, and it can extract that information in that object. So you don't have to worry about like the order of the arguments being passed in like we do here. All right. With that, I'm going to. All right. So we've got our person class set up. We kind of briefly covered dict and keyword arguments, but I'm reverting back to manually passing in each argument in here, just because we want our code to be readable to other programmers. And if we just did school info or just some other arbitrary object, we don't necessarily know specifically what variables we want to store. So I'm coming back to here because this is very easy to read for other developers: name, age, school, password, ID, etc. Same thing with here. Staff person is inheriting the person class. Same thing here. The only difference is we have an employee ID versus a student has a school ID for whatever reason. All right. Does anybody have questions up until this point?
Just kind of a clarifying question with the inheritance. Since you're still having to write out that init statement for the parent class, is the primary thing you're getting from inheriting the attributes that are already kind of set up from the parent class?
So the question is, the main thing I'm inheriting are the attributes from the person class?
Yeah, is that the main kind of point of using inheritance in this instance?
Exactly. Attributes as well as methods as well. So there might be different methods, like a student, for example, just in if you think of like the world as a whole, a person can do like a bunch of different things, like say hello. Maybe the person that says hello just in the real world here is like, it's like, hi, so-and-so, where a student can also say hello. So they'll also be able to inherit the hello method from the person class. So instead of rewriting a hello method in the student class, they can also inherit the hello method from the person class.
Okay, that makes sense. Thank you.
And you can also overwrite methods as well. So the way a person may say hello out in the real world might be different than how a student might say hello in the real world, and I can literally overwrite the hello method inside the student class. But yeah, that's for a later time when we talk about that. But yeah. All right. Yeah, good questions. Clear. So I just want to make sure everything still works. Student, just making sure that works. Okay, I'm able to still create a student. Great. So I'm just going to delete that. I think staff should still work. All right, great. All right, so let's come down here and where we want to actually organize our program a little bit. So let's refactor it by changing around our folder structure. So pretty much in here, we want to have it look something like this. So we want a data directory, which we currently have right here, data. But we have all these classes all on the same level, which we don't necessarily want. So we want to have a classes directory. So I'm going to say, I'm just going to create classes. And I'm going to move the person class, the school class, the staff class, and the student class all inside the person class, or inside the classes directory. And we might have to move around some items or move around how we import some things, but for all intents and purposes, I think this is good for right now. I'm going to delete that. Staff, okay. All right, so the next thing we need to do is load our data from the CSV file using Python's CSV module. If you haven't done so already, read through the docs. We're going to make a design choice here and say that our student class will be in charge of taking or talking to our student database, quote unquote. So before we were just writing functions and everything, we weren't actually, data wasn't persisting after we would execute that function and the program would end. That data did not persist outside of the program. With CSV files, our data can persist now. So we can read and write from CSV files. So we're going to want to write a method called allStudents that returns an array of student objects that represent each row in the student's CSV file. So it looks like we want to run student.allStudents and have it return an array of student objects. All right. So I'm just going to start with students. So in here, let's see what we got. Let's see. All right. Hint, you'll need to import OS path, abstract, blah, blah, blah. All right. So in here, let's go ahead and write a method called def all students. And it looks like, notice right here, what is unique about this syntax?
It doesn't take any parameters in.
Okay, what else? It's not what I'm looking for, but.
It's using the class name.
Yep, look at, I'm using uppercase student dot all students. So it's not an instance of a class. So let's go back here. Oh no, cancel. Let's just do pass. So before, how I was like Tom equals student Tom, age 35, role student, school ID, and password, like so. Typically, when you run a run, it would be run an instance method. We'll do Tom dot like all students, like so. But all students shouldn't just be a instance method. It should be a class method. So where all students typically would pass in the self keyword and be like print like a single student. But here we want to return all the student objects in the student CSV file. So typically we've done instance methods like so. However, we want to be able to run student dot all students and not even have to worry about invoking an instance for this to run. So let's just actually, I'm just gonna run this print all students. So if I were to do the Tom.all students, no such file or directory exists. Where are we? Oh, so CD classes. So I'm no longer in there. So I'm gonna clear. If I do Python student, I get all student. But what if I want to do student without invoking or creating an instance of a student? If I just want to do student slash, oh, I get an error. So does anybody know what I need to convert this specific method into?
You need to make it a class method.
A class. What is a class method?
It's like a method that can run like alone from an instance.
Yep. So a class method is specifically a method that can execute on its own without relying on an instance to be created. So there's a way we can do that. There's these things called decorator functions, and I'm going to just create it, class method. So above whatever method I want to create a class method, I do at class method, and this is specifically called a decorator function. And a decorator function essentially extends the functionality of whatever function it encapsulates. So this class method function takes in a class object like student, and then it runs whatever, it just executes this function. So it doesn't rely on a instance. So and instead of taking the self keyword, because self refers to an instance of itself, like an instance, this takes in a class, which is referencing the class of student. So now if I run this, I can print all students. But if I got rid of that class method, I'll get an error. So this class method, think of it as a function that's in the realm of Python. That's called a decorator function, and we'll cover decorators later, but just know that this at class method is a function that takes in a student class and essentially just executes this all students function.
Quick question, Tom.
Yep.
For the class method, that CLS that has to be specific to that decorator, right? Like it has to be that exact.
I think you can still pass in something there, but you want to pass in arguments based off of like what is actually being passed in there. So we're actually passing in the class in there. All right, all students. Cool. All right. So in this all students function, we want to be able to open up the CSV file, the student CSV file, loop through each student, create a student object with this data, and then store it into an array. So in here, we'll want to, how do we open up a CSV file? So we'll do open
with pass
as some path. So I'm guessing the path to this data, I can go up one file into data / students CSV as I'm going to call this as a student file. What's going on here? So it says, student file is not accessed. Statements must be separated by 2 lines or semicolons. Oh, is this the right syntax?
Is it with open?
With open. All right. Now I'm going to open up Python, the docs. So it looks like we have CSV reader, CSV writer. We're not writing to the CSV. So we can probably use a writer, a reader, or there's just also dict reader. Creates an object that operates like a regular reader, but maps information in each row to a dictionary, a dict. So again, first thing I need to do at the very top is import the CSV library. And let's see if I can do this. So I can say student reader equals CSV. Do we want it to be a reader or a dict reader? Look, I've got 2 of them here.
For this case, I think you want a dict reader because it's going to pass in values a little easier to your call student function or staff.
Yeah, let's see, dict reader. So I'm going to pass in the student file in there. I'm just going to print the student reader. I don't know what that looks like. So student reader. All right, let's see what happens if I do that. And then down here, I'm actually invoking that. Clear. Cool, I get a dict reader object. Okay, it doesn't really help me. All right, so so if I do for row in student reader, let's just print the row. I don't know if this is gonna work. Cool. Look at it. I've got an object of name, Lisa, age. So I've got an object of all the students. Now, if I did, instead of dict reader, just reader, let's see what that looked like if I did the same thing. Okay. It looks like it's just an array. The first row is the headers, and then an array of each value. So in here, I'd have to like memorize the index of what the age is. So the age is index 1, but you never really want to hard code that stuff. So yeah, a dict reader would be better in this situation because I actually go explicitly, hey, this is the name, here's their age, etc. Cool. And again, I want to create a student object out of all these. So if I'm looping through each row, can I pass in this entire dictionary as an object, or pass this information into the student and invoke and create a new student? So I'm going to say, I'm going to create a variable because we want to eventually have an array of student objects. So I'm going to say student array, because an empty array. And if I wanted to create a brand new student object, so I can create like student equals, I'm creating a brand new student instance right here. I'm going to pass in the row. I can do age, because again, or I guess it would be name first. So name, and this might be where the keyword arguments might come in handy, because I have to worry about placement here. Row dot roll row school ID row password. So what's happening here is in the all students method, I'm opening up this student CSV file as student file. I'm creating a student reader, which is a dict object. Where it was all the way up there. And then I'm looping through each row. And before I was printing each row. So each row is being printed down here. With that, for each row, I'm creating a brand new student instance for each, so I'm creating multiple student instances. So each loop creates a brand new student instance, passes in the name, age, role, school ID, and password. So name, age, role, school ID, and password, and creates a brand new student instant object. I'm just going to print each student object out here. See, now I've got a bunch of different student objects, and I can do student.name just to make sure I've got a bunch of different students. Lisa, Jesse, Slater, Kim, Dave, Doug. Questions about creating brand new instances within this all students method? All right. Now I can append student array dot append each student object. So each instance of a student, I'm appending to the student array. And after it loops through that entire that dict object, I can just return student array. All right, so I'm going to clear that. And let's actually print student array just to see if we can see all those objects, that array of student objects. There we go. We have an array of student objects. And each object has attributes, name, age, role, school ID, and password. I can even cut down on this. Instead of, I can even get rid of that and just pass in each instance of a student like so. So I'm literally just passing in a brand new student instance in here and creating it simultaneously and appending it. Questions of how I'm doing that? Nope. All right. So if I look down here, inside, so I'm going to have to do that as well with staff. So I'm just going to copy over all of this to staff and do something very similar. All staff, create staff, create a new staff person, age, rate, instead of school ID, I'll do employee ID. I'm gonna have to import CSV up here as well. All right, instead of student reader, I should create all this to staff. All right, so that should also work. All right, it says OS path, but I have it working right now. If I have to refactor it, let's go ahead and do that. But let's go to release 3, load staff and students into school. All right, so where is my school? So here's my school class. So I'm going to have to import student from student, or no, import, is it from student, import the student class, and from staff, import the staff class. And down here, when I'm initializing a brand new school, I want it to automatically return an array of staff and students in here. So again, these are instance methods. So I can say student dot all students, invoke that. And again, this all students array or all students method returns an array of student objects. So this self.students will be an array of student objects. Likewise with staff.all staff and invoke that. All right. Let's just see if this works. Let's go to our runner file now and print school.students and also print school.staff. All right, so let's run that. So we're there. So pretty much we want to do something like that and print the school and staff. So I'm going to Python. So I'm currently listed. I'm currently in the classes directory. I need to go up one level to where my runner file is. I can do Python runner. and I get an error. So it says from school, import school, no module named school found. So it's saying, hey, from the school. So from school, import school, but it doesn't know where school is located at because it's located in the classes directory. All right. So I need to go in the classes directory .school, import school. Great. So if I clear that and run that, oh crap. It says from student import student. So inside the school.py file, so I'm in the school.py file. It says from student import student, and that's where the error is. No module name student. But I'm in the school right here, and this right here, and the student directory is in the same directory as my student, and it's throwing an error. Can somebody help me out? And how do I correctly import the student module or student file in the school file?
Would you do from classes.student, import student?
Okay, it's from classes.student, import student. But that's kind of weird because like my school class and my student class are in the same directory. So wouldn't it be like, shouldn't there be like a note the way this
classes?
shouldn't, I'm just,
Yeah, I think a lot of us were struggling with this yesterday.
okay.
I think it's because you're executing it from runner.py, so it's looking for the files relative to where runner.py is, and it doesn't know to look in the classes directory, even though the classes are in the same directory.
Yeah, the way I fixed this is with Chris's solution from last night. Runner.py has that import statement. You just got to convert your classes to have dot student import student and dot person import person, and that seems to fix it. And it works in all cases where you can like run stuff from inside of a given class and doesn't error out, and also the runner work.
Okay. Yep. But as you said, it's relative to where your file is executed is where all the import statements, like where the directory should be. So if my runner file is ran one level above like the school class or the school file is located at, I'll need to do classes.staff because in order to get to the staff directory or the staff file, I need to go into classes.staffs, classes.student, etc. So here we said from person, again, no module not found. All right, I created classes.staff. Oh, but so it went into the school, it aired out here. I add classes. Now it says no module name person in the student.py file. So again, I'm going to come over here and it looks like person. I can do classes dot person right there. I'm guessing I'm going to have to do that same thing with staff or with the inside the, the staff. There we go. So if I clear everything out, hopefully everything's imported correctly. And let's see, run that. Uh-oh, no such file directory. Where am I at? Runner line 1, school.line 1, students line 23. What is this, student? All right, let's get rid of that because I don't need this anymore. Maybe there's some error right there. Uh-oh. Here we go, student line 11. All right, right here. So no file or directory data.students. This is where I need to give the absolute path of where this CSV file is located on my local machine. So in here, we'll have to import OS, import OS, and then do my path equals os dot path, grab the absolute path, which is os path name dot directory name, whatever that file is. So let's actually print that out first. So Python or print my path and see where that is located. See what prints out. I don't know. Uh-oh. So let's actually just comment this line out here first. Pass. It's probably going to do the same thing for staff. Clear. So here's the student, my path, users, TP, desktop, CP challenges, Oscar challenges, school interface 1 classes. That's my current working directory right now. That's where I'm located at, where this file student is located at. So what I want to do is path equals os.path. I'm going to join the my path and then go up one level to data. So I'm currently located in here with my path. Now I want to go up one level, which is doing data into students.csv. And now that's the absolute path to where the students file is located at. I can test that by running path or print path, clear that. And now you can see if I come over here into classes, I go up one level to data, students.csv. Now that's the direct location of where my students.csv file is located at. So in place of hard coding, specifically where the path is in relation to the student, I can run that. I can do the same thing for staff. That should be the same. There we go. So in here's the path to students. I'm opening with the path there, and everything should still work. There we go. I'm printing off the students, which is a student object, and the staff, which is an array of staff objects. And school.students is an array of student objects. And that's where I am right there. And that's school interface 1. What questions do you have?